Binary operations, the closure property. The closure property is among other properties of binary operations, such as the distributive property, associative property, commutative property, inverse property, identity property. So let's look at the closure property. A known entity set S is said to be closed under a binary operation star if for all A and B, which are members of the set S, A star B is a member of set S, or a set M is said to be closed with respect to the binary operation star if for any two elements A, B, which are members of the set M, A star B produces another element which belongs to set M. So this is what we're trying to say. If the set M has members 1, 2, 3, 4, 5, 6, 7, 8. These are the members of the set M. Now, the closure property holds that if we combine any two elements from the set M, the binary operation has to do with a rule of combination between just two elements. So if there's a rule of combination between any two members of this set M, such that the result of that combination also belongs to this set M, that means that binary operation is closed under the operation of that binary operation. So let's say actually A star B is equal to let's assume 2A minus B. So let's say okay, let's pick randomly any two elements from the set M. So let's say 3 star 4. Take note that we pick these two elements from the set M. So if we use this rule of combination to combine these two elements from the set M and we get the result, if the final result also belongs to the set M, that means this operation star is closed on set M, or set M is closed under the operation star. That's all the closure property is all about. There is a theory star for using this operation 2. What are E is 3 times 3 minus 4. 2 times 3 is 6, 6 minus 4, that's equal to 2. Is 2 a member of this element of this set? Yes. So this means that therefore the set M is closed under the operation star. That's the implication. So it's the rule of combination. It's the set M is said to be closed with respect to a binary operation star if for any two elements A, B. So if any two elements is combined using the rule of combination that is given, or even using the operation that is given to you, if you use that to combine any two elements from a given set such that the final result also belongs or is a member of that set, then that operation is said to be closed, or that set is said to be closed under the binary operation. So that's all the closure property is all about. It must belong to this set where you took two elements and combine together. So if it doesn't belong to that set, that means the set is not closed. Let's take another example. Starting from this set, let's say the rule of combination is x star y is equal to 3x minus y plus 3. Okay, so let's also take 3 times 3 star 4. 3 times x, 3 times 3 minus 4 plus 3. 3 times 3 is 9 minus 4 plus 3. 9 minus 4 is 5 plus 3. That's equal to 8. Is 8 a member of the set M? Yes. So if 8 is a member of the set M, that means the set M is closed under the binary operation star. Let's say 4 star 5 so 3 times 4 minus 5 plus 3. 3 times 4 is 12, 12 minus 5 plus 3. So 12 minus 5 is 7, 7 plus 3 is 10. So 10 is 10 the number of the set n? No. So if 10 is not the number of the set n, that means the set n is not closed. That's what it implies. It's not closed because it's not closed on that star. So what it means is that two elements from the set n was combined using this rule of combination, and then the result of that combination produced a third element or third number which is not a member of the set n. So as long as it's not a member of the set n, it implies that set n is not closed under star. So when it's a member of the set n, it implies that set n is closed under the star operation. So that's what the closure property is all about. An operation star is defined on a set of real numbers R such that if x, y members of set R, if x, y are members of the set R, then x star y is equal to x plus y over 2. So the first thing we need to do is to write the rule of combination x star y is equal to x plus y over 2. Next is a to determine to restart 2. So our x is 3 and our y is 2. So that's what we put in each of these letters. Plus 3 plus 2 over 2. 3 plus 2 is 5 over 2. B is minus 5 star 4. That's equal to minus 5 plus 4 over 2. 1 over 2 minus 1 over 2. And C is 7 star 3. 7 star 3 is equal to 7 plus 3 over 2. 10 over 2 is equal to 5. And D is equal to 1 over 2 star 1 over 2. This will give us 1 over 2 plus 1 over 2 over 2. 1 over 2 plus 1 over 2 will give us 1 and then over 2. Okay, that's our answer. Now, if when we have an operation star is defined on the set of real numbers, so the set of real numbers is going to be an infinite set in the sense that we cannot list out all the members of that set. But what we know about real numbers is that real numbers are numbers that involve positive numbers, negative numbers, fractions, and decimals. So any number that is real has to do with numbers that we know in mathematics that we work with. We have at the negative numbers, fractions, decimal numbers, they all belong to the set real numbers. So therefore, this rule of combination produce x star y, which is x plus y over to produce elements or produce results of elements which are also members of the set of real numbers. So what do we say from this? The question says, is the set R closed under the operation? We say therefore the set R is closed. The set R is closed under the binary operation star. The binary operation star, because all the elements produced from the combination, they all belong to the set R. An operation which is this is defined on the set S. So these are the members of the set S by x operation y equals to x plus y minus xy. So x operation y, x plus y minus y. This is the rule of combination. So for us to determine if the operation is closed, is that in each case, when we combine the elements given to us, if they produce a third element that belongs to this set S, that means the operation starts closed. If in all these options, in all these categories A, B, C, D, if one of them does not belong to the set S, if the result produced by either A or B or C or D does not belong to the set S, for the sake of that one that doesn't, for the sake of that option or that figure, for the sake of that number that did not produce a third element that belongs to the set S, that means the operation would not be closed under the set rather would not be closed under the operation. Let's take it. Okay, what I mean is that assuming we work on E and discover that the answer from the combination of 2 and 5 produce a third element that belongs to the set S, and then we work on B, the answer also is in the set S. C, yes, set S. D did not produce a third element that belongs to the set S. So for the sake of D, that's the answer we got from this combining these two elements, that which does not belong to the set S, that means that the operation, the set S, is not closed under the operation, under this operation. So even if the previous theory, the answers are in the set S or belong to the set S, so if only one does not belong to the set S, that means it disqualifies the set from being closed under the operation. So A is equal to, so A we are going to do 2 operation 5. Let's see what that will give us. 2 plus 5 minus 2 times 5. And so 2 plus 5 is 7. 2 times 5 is 10. And then 7 minus 10 is minus 3. Now, is minus 3 a member of this set? Minus 3 is the third element produced from combining 2 and 5 using this rule of combination. And we discover that minus 3, which are two elements from this set S, produce a third element under this operation, produce a third element which does not belong to this set S. Therefore, from this alone, this set S is not closed under this operation. So we only say for now, we say 2, therefore 2 operation 5 is not okay. So minus 2 is not a member of the set S. Okay, so let's bear that in mind. Therefore, minus 3 is not a member of set S. This says 0 operation 4. That's 0 plus 4. 0 plus 4 minus 0 times 4. 0 plus 4 is 4. And 0 times 4 is 0. And 4 minus 0 is 4. Is 4 a member of the set S? Yeah, let's see. Yes, 4 is a member of the set S. 4 is a member of the set S. C. Theory operation 1. 3 plus 1 minus 3 times 1. 4 minus 3 is equal to 1. So C. Therefore, 1 is a member of the set S. D. For operation 5. 4 plus 5 minus 4 times 5. 9 minus 20 minus 11. From what we can see, we don't have minus 11 in this set. Therefore, minus 11 is not. Therefore, minus 11 is not a member of the set S. Now, looking at the final result, the third element produced from combining 2 and 5 does not produce. So the third element produced from combining 2 and 5 is not a member of the set S. From D, the third element minus 11 produced from combining 4 and 5, which are members of the set S. 4 and 5 does not belong to the set S also. So for this reason, yeah. Okay, so it says since minus 3, since minus 3 and minus 11 are not members of the set S, and set S is therefore the set S is not closed. It's not closed under the binary operation